Imagine you are a tiny speck floating through a void, and all of a sudden you get pushed and pulled and slammed into a bunch of other tiny specks. And just as soon as you get comfortable, you get pushed out and then pulled back in and slammed around again. Well, this is just one thing that subatomic particles, or the things that make up atoms, go through every second of every day to make up the world we know. Subatomic particles have been doing this since the dawn of time. And because of my love for chemistry and me going and majoring into chemistry, these have piqued my interest. And today, I would like to reveal the secrets behind neutrons, protons, and electrons on how and why they help to form the world we know. To begin, the neutron, a neutrally charged subatomic particle, keeps protons in the nucleus with what's called the strong force, according to the US Department of Energy. Sometimes this is referred to as the strong nuclear force. This force can't even have a tiny bit of space in between what it's affecting, so it would never happen on a world this scale. Why are these important though? Well, according to EBSCO, they help stabilize atoms. An unstable atom releases what's called alpha decay, or comet radiation, where 2 neutrons and 2 protons get launched out of a nucleus, and it can be pretty damaging. They also allow for protons not to magnetically repel themselves. Protons are the positively charged particles, and if they did not have neutrons in between them, we wouldn't have nucleus or matter as we know it today. While neutrons may be able to stabilize atoms, they can also make atoms unstable. If you put more neutrons into an atom than it wants to have, it can split. This process is called fission. And according to EBSCO, it can give us nuclear bombs to the most clean energy and efficient energy that we have today in nuclear power plants. But now that we know more about the neutral neutron, let's move on to its positive partner, the proton. The proton is a positively charged subatomic particle, and it's held together in the nucleus by a strong force to the neutrons. If there were no neutrons, protons would kick each other out of the nucleus, and we wouldn't have anything like we see today. Why are these important? Well, they make up the elements themselves. Protons determine the atomic number of an element. So let's go helium, for example. Helium has 2 protons, so its atomic number is 2. Protons plus neutrons also equal the atomic mass. This allows scientists to determine the stability of an atom. Protons also determine acidity. When an acidic substance is put into water, it releases protons, or H, into the water. H is hydrogen, and when this H is released, it gives us a pH, or the basic label for acidity. Protons are also stable on their own, and unlike the neutrons that will split into 3 different parts, the protons will actually just form hydrogen gas, one of the most important gases on Earth. But since we know more about the 2 most stable parts, let's move on to the most excited one, electrons. Electrons are the most negative subatomic particle. There is no strong force holding them around an atom because they're much too far away, just kind of like how the Earth is with the moon. Instead, they're held in a space called an orbital by protons' positive charge because electrons are negatively charged. And why are they important? Well, the octet rule says that atoms generally want to have 8 electrons on their outer shell. And let's take oxygen for example. Oxygen has 6 electrons in its outer shell and wants 2 more. And hydrogen, an exception to the octet rule, has 1 electron and wants 2. So, if you put 2 hydrogen and an oxygen together, they give you H2O, water. The octet rule allows for everything we know to exist. And not only do electrons create bonds, but they can also create magnetism. If electrons favor one side of the atom, the other side gets positively charged, and this side, the side that the electrons are on, would be negatively charged. And to conclude, the world would not exist without these 3 unfathomably small particles. however small, neutrons, protons, and electrons make things from you to the stars in the sky. And an astronomer, Carl Sagan, once said, "So an elementary particle, such as an electron, would, if penetrated, reveal itself to be an entire closed universe. Within it are much other tinier particles, which are themselves universes at the next level." Thank you.